Welcome at the Ask Professor, the last one of this MOOC. Hopefully you enjoyed. I did. I hopefully see you back, but later I will tell more about this. First, let's go for the questions. I get a really nice question about where, and the question was, do we really need a system or a software or monitoring real time of where? And then I really think about the question, is this really necessary? When you are really honest to yourself and you look at the real wear of the rail, that's only a few millimeters per, what is it, in 10 years or 5 years. So how quick you need this information? When you talk about real time, then it's not necessary to do this real time, because in 1 year you only lose 0.3 millimeters of rail, of the steel, of the dimensions. So that's almost nothing. So why should you do this real time? When you talk about real time, I would focus, for example, on the RCF, rolling contact fatigue, the cracks, the real problems in the rail while a rail can break, and that's safety. So for safety issues, I would say yes, please. But for wear, just the wear and tear of material getting off in the real rail contact, I would say don't do it. That's a waste of time and money. A second question in line of this wear question was about can you see any difference when you have different traction, like diesel motor or an electrical motor, and a different rolling stock, a different locomotive? Is there anything you can see when it is in operation? And the question is yes, you can. We have a really actual issue in the Netherlands on the high-speed line. Normally we had the high-speed line, we ordered new rolling stock, but then there was some issues with the supplier. Can happen, of course. It's human beings, and they will always make mistakes. So that's the issue. But okay, when we need these operations, and there was no any other rolling stock available. So what did we do? We make a decision and say, why not using a tracks? That's a locomotive, can drive 200. It's not high speed, but okay. But it was available. The problem with the tracks locomotives is that they are designed for freight and not for high speed. And what happened in the construction is that when you have freight, then they said, okay, no high speed, no high demands on the track, while when you have designed on the spot for 300 kilometers an hour, we have a special designed high-speed line infrastructure. And that's totally different. So the match between this rolling stock, a freight locomotive on a high-speed design infra management, that doesn't work at all. What you see is that normally you get, for example, cracks in the top rail. You get these cracks in the lower rail because the dimensions in a curve are not correct. Normally you have this cant efficiency or deficiency. Then you need this balance, and that's depending on the speed. What happens now is that the speed was too low. We have a heavy locomotive, cannot drive this speed, so all the dynamics are going to the lower leg of this curve. And that means, and then we have also another issue, that the suspension on the motor was not fully suspended. Now we only have a suspension on the half of the motor weight. And that means that when you have some problems by geometry, it bumps really hard because half of the motor weight, say 1,500 kilos, was also bumping and dynamics on the construction of this infra. And then you get really other issues. So when you have really hammering on the construction, you get really cracks in the concrete as well. And it was slab track. So all these issues will pile up. And when you make the summation, you get really issues. It's not only the wear, no, it's about demolishing the full construction, and you get strange cracks in a not normal situation. So that is the influence of making the wrong choice, rolling stock, with the wrong design of infra. So be careful with that. While we are talking about cracks, I still like to show you how we can see cracks, for example, in transition zone. So it's not only on the rail, so on the steel parts, but also in the transition zone, because we have a hard point, that's a bridge, for example, that's concrete. We have piled the foundation, and that's really solid. And we have the embankments and the construction of the normal system of the rail. It's not heavy rail, it's not normal rail, it's tram rail. Don't worry, it's more or less the same situation. And there you see in the transition, so the transition from solid to normal embankment or the normal construction of a street. We have a nice video I made. It's outside, it's not in my room, but it's outside, so please have a look at that and be careful and look carefully to these transition zones and the cracks you see over there. Welcome everybody. We are now standing here somewhere in the center of Delft City. I'm standing here directly on the solid soil, and where the camera guy and going to the front, we see an overspan of about 30 meters. That's a problem because we have a transition zone, solid soil and solid concrete, and then we have dynamics problems. And how you can see this, that this is really a problem, that's exactly because we have here a crack. We have a crack over here when the people and the pavement are walking. We have a crack over here when the bikes are going over in the asphalt, and we have a problem over here when these buses are running over, and also we have the track for the tram. And there we have these cracks in the soil, in the asphalt, in the plain road, and also on the road over there you see the cracks as well. How can you stop this? Normally you need a relax zone, a relax of tension, and therefore we have this special construction over here in the tram construction, that the rail can breathe and can have expansion when it is sunshine, or shrink when we have frozen nights. This construction is normally working fine. You can see that the construction inside is working fine, but outside we see the asphalt is really shrinking, cracking, and coming out around this construction of steel. And that's because we have different materials, dynamics by the buses and the tram, and therefore we get these problems on this track. How to solve this, make it better and more robust to fix it. Thank you very much. I really enjoyed. Nice questions, also in-depth questions. So when you like to go on with in-depth knowledge and see what you can get out on our online education courses, then I really recommend you to go on and enroll yourself for the professional education of rail of TU Delft. Please enroll yourself, look at the links we can send you. It's not free, sorry, you have to pay something. It's almost nothing, I think, but you learn a lot. You're not alone. We have a lot of international students who make this difference. You get in-depth knowledge and courses on all kinds of topics, from design till maintenance and the long term, and also operations. And in the end, you have a capstone project. You can bring in your own problem and dig it out to find the solution as a system approach. So I think it's really exciting. When you're excited as well, please enroll yourself, and maybe I see you back. Thank you.